we did in class, we did a little lesson on completing the square. And now, you basically took a expression and you put it in factored form. So now we're going to do the same thing, but with equations, specific types of quadratics. These are trinomials that are in standard form, and it's x squared plus some number x plus another number, or minus another number. This could be a minus sign too. But the key thing here is every one of the coefficients, every one of the numbers in front of x squared is actually going to be 1. If you put a 2 in front, you can't do it the way I'm going to show you how to do it in these problems. So the first thing is thinking about when you have, x squared plus 7x plus 6, and we don't even really need the y equals. That just, we know that this is the expression that we're going to actually turn into a multiplication problem. So the first thing is to understand what this means. Well, x squared, there's one of them, so here's the x squared term, and each one of these greens are 7x, and then, 6. So this amount, these are the little ones, and the greens are the x's, so there's 7 of these x's, and there's 6 of these little ones. So putting this, factoring it would mean turning this expression, all of this area, but we're going to make it into a rectangle so we can say that it's length times width to get to this one. So we're trying to figure out what length times what width if it was a rectangle. So would actually equal this entire expression, which is right here. So first of all, I tried to move this around, and this obviously doesn't form a rectangle. So what I'm going to do is I'm going to move this one over here, and I'm going to make the x go the other way. And you can see by doing this, I've taken the 7 x's and the 6 ones and the x squared, and I've turned them into a rectangle. Well, this kind of shows me what it should factor into. Because the length and width of this now, here's an x, and then this right here is represented by the length from here of the ones place. So here's an x, here's a 1, and on this side, this length of this is one green one across, so that's an x. Because remember, x squared comes from x times x. And then all the way across down the road, I could count 1, 2, 3, 4, 5, 6 places. Well, these are all positive greens, and this is a positive 1. So I can see how this expression right here in standard form would be in factored form x plus 1 times x plus 6, since length times width would get us. And if you did multiply these two binomials together, you will end up definitely with this standard form. So that's how you factor in using algebra tiles. But there's almost an easier way to do this. If you think about the expression, when it's in this exact form, and especially when there's a 1 in front of the x squared, you remember that the number in front of the x squared is a. We know a is going to be 1, b is going to be 7, and c is going to be 6. Well, if you could think of the two things that multiply to c, but those same numbers also have to add to b. So when I look at c, it's 6. So there's a couple things that multiply to get you 6. 6 times 1. You can do 1 times 6, 3 times 2, and then obviously 2 times 2. And those are all the factors of 6. Well, do any of these add to 7? Well, either one of these do, because 6 plus 1 or 1 plus 6 will get 7. So either one of these will do. And when you think of the two things that do meet this criteria, that multiply to c but add to c, we can turn them into the two binomials. First of all, to get x squared, you always multiply x times x. And then you could take the two things, and it doesn't matter which way you put them, because they're both positive, positive 6 and positive 1. And you could check that if you multiply this, you will end back up at this problem. So let me show you another one of those. Again, here's another trinomial, and the number in front of the a squared, just to make sure, is 1. And don't be fooled by the variable being a. We still call the number in front of the exponent that's being squared, a. The b in this case is 8. And the c in this case is 15. So instead of taking out an a squared block, 8 of the a's, so 8 of those long strips and 15 of the ones, to see how to turn it into a rectangle, I can just say to myself, what things multiply to get to c, but then add to that middle term, which is the b, which is 8, positive 8. So 15, there's 3 times 5, there's 15 times 1, and then as soon as I said it, I remember that 3 times 5 is 15, and 3 times plus 5 is 8. So those are the two things that are going to be in our binomials. So the factored form of this trinomial would be a, you could either do plus 3 or plus 5, and the other one. And I promise you, if you multiply these two together, you will end up with a squared plus 8a plus 15. Which, by the way, if you check this, if you think about what this would look like, I have my a squared, and then I know that there's going to be 3 on this side. So I put my a, my a, my a. Here's the 1, 2, and 3. So here's a plus 3. And on this side you have a, and I know it's going to be plus 5. So I'm going to go 1, 2, 3, 4, and 5. Oh. And here are all my other a's. And now you can see that how many a's do I have? Well, there's 5 here and there's 3 here, which will get me the 8 a's that are in my expression. And if you use the 15 little blocks, you have to trust me on this one, I didn't really draw this great, but if you use the 15 ones, they'll fit right inside here, and you will have a rectangle, a complete rectangle, which shows why this is the factored form. Now let's see if you can do some. I'm going to go ahead and give you some more problems. I want you to do them and pause the video and watch me do them, okay? So go ahead and pause the video, and when you're done, you can go ahead and play it. This one, the two things that multiply to 30 but add to 13 are, well, it's not 15 and 2, it's not 6 and 5, but what about 3 and 10? So your factored form would be y plus 3 times y plus 10. Go ahead and pause the video for this one. Now, and then play it when you're done. This one was a little bit more complicated because not only did you have to multiply to a positive number, but when you added them, you got a negative number. Well, the only way that that would happen is if both numbers happen to be negative, because a negative times a negative is a positive. So what numbers multiply to a 72? Well, 8 and 9. And if you think about it, negative 8 and negative 9, when you multiply them, then you do get a positive 72. But when you add them, you get a negative 17. Negative 8 plus negative 9 is negative 17. So our factored form is p minus 8. And it doesn't matter if you wrote p minus 9 first. That would have been fine. Times p minus 9. Now go ahead and try this one, and then play it when you're done. This one, you're multiplying to a negative number, but adding to the b is actually a positive 1b. So thinking about the things that multiply negative 20, negative 5 times 4, but that would actually add to negative 1, and we have to add to a positive 1. So the way that we can fix that is multiplying a positive 5 times a negative 4. So our factored form is b plus 5 times b minus 4. And you could have switched them to b minus 4 times b plus 5. But either way, this expression, if you actually multiplied it out, the factored form would get you back to b squared plus 1b minus 20. Okay, I think we have one more left. So go ahead and, no, I'm sorry, 2 more left. Go ahead and do this one and then replay it. This one, thinking of things that actually multiply to a negative 1. So here I have the two things that multiply to negative 42 or negative 7 and 6. There's a lot of things, but these are the only ones that add to negative 1. So our our factored form is y minus 7 times y plus 6. And again, you could have moved the y plus 6 over here, as long as the 6 was the positive one and the 7 was the negative one. One last one. Here, the first thing we're going to do is we have to, I like to write it in standard form. So even though the x squared is last, it's positive x squared, it's positive 13x, and it's negative 30. So here we're multiplying to a negative 30, but adding to a positive 13. So thinking of all the things that get you negative 30, you can do negative 3 and positive 10, but those don't actually add to positive 13, and neither does negative 10 and positive 3. So maybe 6 and 5 if one of them was negative. No, those don't actually, regardless of which one you do, those don't add to a positive 13. So now we have 15 and 2. And that's going to be the one that works. Now, thinking about that, we got to add to a positive number. So the bigger number is going to be positive. The smaller number is going to be negative. So our expression, our factored form of that expression is x plus 15 times x minus 2. Okay. Hope that helps.